Hello everyone, Mark Dijkstra here, your friendly neighborhood finance professor, and today I'm back with lecture number 8 in our corporate valuation for finance course, and here I'm going to talk about multiples, or so-called relative valuation. So far we focused on DCF analysis, so discounted cash flow, where we get the fundamental value, or at least we try to get the fundamental value of any asset. And relative valuation is trying to find the value of an asset relative to other assets in the same asset class. So easiest example to think about is that suppose I am selling my house. And I'm selling my house, and let's say I'm selling my house and my house has, let's say, 100 square meters in surface area. And then I know that in the neighborhood, another one of my neighbors just sold their house of 150 square meters or so for, let's say, 450K, so 450,000 euros or so. Then what I can do is say, well, if I then look at, if let's say my house is the same quality, if there's a linear relationship between house price and surface area, then what I can do is say, well, this means that they're paying 3,000 euros per square meter, so that means that my house should be worth 300K in euros. And this is the essence of really what relative valuation is. So you look at comparable assets that are very similar to the asset you're valuing, then hopefully those assets have a certain market value, and then you apply that market value through a multiple to your asset. So to perform relative valuation, first identify comparable assets, get market values for those assets, convert the market values into these standardized values, so multiples. So in this case, market value, so the market value per square meter. And then compare that multiple to the asset that you're actually analyzing. So in this case, a house that is 100 square meters. If we then have 3,000 euros per square meter, then I know the price of my house. And then, more or less we can conclude what the value should be, and then we can compare it to its actual value. So relative valuation, it's a fairly popular way to do things because, well, it's relatively easy to do. Here I have a quiz question where, in principle, this is all you need to know about applying multiples. So even in slide number 2 or 3, you know everything you need to know about applying multiples, or at least let's see if you do, because first you have to get the question right, of course. So here, suppose we observe two companies. So company A has share price of 6 and earnings per share of 2. Share B has a price of 8 and earnings per share of 4. If company C has 4,000 shares outstanding and net income of 6,000, what share price do you expect for share C? So here you have market values for company A, company B. You can standardize them by their earnings per share and then apply that to share number C. And I'll give you a moment to do that. And here I get a value of 3.75, because if we look at the price over the earnings per share for company A, that is 6 over 2, so that's 3. And for B, that is going to be 8 over 4, so that's 2. So that means that on average, people are paying, well, 2.5 times the earnings in terms of the share price. So for each earnings per share, the share price is about 2.5 times as much. People are paying 2.5 times the earnings for each share. So if we then have the earnings per share for share C, which is 6,000 over 4,000, that is 1.5. That means that we expect the price for C to be 1.5 times 2.5. So, and this is really all you need to know for the application of relative valuation. So it's very quick, it's very easy to do, and this also makes relative valuation very popular. So De Modern always gives this number where he did a survey of about 500 equity research reports, and he said 85% of those equity research reports are based upon a multiple, and 50% of all acquisition valuations are based on multiples. Now, I trust Darren that he actually did the work, but the problem is I couldn't really find the paper to back up this quote, so take it with a small grain of salt. Why is relative valuation is so popular? Because it's so easy, and this is also why people really like it, and why you should know how to use it and how to, well, not abuse it. Because one thing that makes relative valuation very nice is that it's relatively easy also to explain to someone that is just to, let's say, one of your managers that maybe didn't study finance or didn't do valuation. So, because the thing is, if you want to present a DCF valuation to someone who's not really that informed about exactly what goes into a DCF valuation, well, then things can get very complicated very quickly, right? Where you say, yeah, okay, so where your manager says, okay, how do you get to this number? And you will say, yeah, first I assume the growth rate of 4% in the first 4 years, and then slowly declines to 2%, and I assume profit margin of this, and a bet of this, which translates into cost. Your manager will have left the conversation completely. Maybe they're still physically there, but in the back of their mind, they are already thinking about which shows on Netflix they will watch tonight. So it's typically way easier to say, hey, on average, people are paying 5 times the earnings per share in terms of the share price. For this company, you only need to pay 3 times the earnings per share. So this seems undervalued. Let's buy it. And that is a way shorter pitch, which is, of course, very nice to have. Also note that discounted cash flow analysis and multiples, they kind of reinforce one another. So on the one hand, even if you are this true believer in DCF and you think the only way to value any asset is to get to its fundamental value using DCF analysis, it still helps to have this multiples valuation to kind of triangulate these values to see, hey, if I use another approach, namely a multiples analysis, do I actually get the same value? If not, maybe there's an error, maybe there's something I need to recheck, or maybe simply the market's overvaluing this asset. So in this sense, multiples can really help. The problem is that sometimes multiples are seen as the absolute truth, and then used to kind of defend where a DCF ends up. So if you come up with a certain value of an asset using multiples analysis and then work your way backwards with the DCF analysis to kind of inform your decisions, then, well, you're kind of abusing multiples and taking too much of what these multiples say as the absolute truth. So the problem with multiples is not so much it's their use, they're very useful, they are in their abuse. So if you put too much faith in what they actually are. And one way to kind of think about that is in this quiz question. So let's say you run into an analyst and this analyst says, yeah, I never do DCF analysis because it requires too many assumptions. You need to assume about cash flows, you need to assume growth, you need to assume risk, etc., etc. They argue it's far simpler to use a multiple like PE ratio, EV to EBITDA, obtained by looking at other firms, and then you can get another value immediately. Are they right? And well, we just spent a long time to do DCF analysis, so let's say hopefully the answer is not that surprising that indeed they are not right. Because yeah, multiples, they have their own implicit assumptions, just like DCF, and I'll talk more about that in the next part of the lecture. But just to give a couple of, to inform like these other answers why they're not correct. So multiples require fewer assumptions. Well, that's not true. They require fewer inputs, but that doesn't mean that they require fewer assumptions. And we'll talk about that in the next part of the lecture, because the assumptions that go into multiples are somewhat implicit. Multiples give a better estimate, yeah, can be, but it's not always the case. Sometimes DCF analysis gives a better estimate, and DCF is more intricate, so it must be better. That's obviously not the case. So a more intricate model Can be better, doesn't have to be better. All depends. Everything is relative. So what does a multiple usually look like? A multiple usually has in the numerator what you're paying for the asset, in the denominator what you're getting in return. Like for instance, one multiple that's used a lot is the price earnings ratio. So price is what you're paying for a certain stock. Earnings is, hey, what is the net income that I'm receiving out of this stock? So what am I paying for the net income that I'm receiving? But they can be more or less anything. But so in the numerator, you can also have the market value of the firm. You can have the enterprise value, and in the denominator, you can have other stuff as well. You can have EBIT, EBITDA. You can have the book value of equity. Whatever you fancy. But most of these multiples will have some will kind of look like look the same in terms of that in the numerator is what you're paying for it, and the denominator what you're getting in return. So what do you do for when you're making a multiple? There's 4 steps. The first is to define the multiple, second is to describe the multiple, third is to analyze the multiple, and then 5 is to apply the multiple. And I've put a step 4 in after step 3 where you want to think a little bit about the multiples that the fundamentals that drive the multiple. So let's start by defining the multiple. So what is critical in defining this multiple? The first is to consistently define the multiple so that both the value, so the numerator and the denominator are to the same claim holders. So for instance, if you're looking for an equity multiple, look for a value that goes, a value for the numerator that has to do with the equity, and a denominator that also has to do with the equity. Yeah? So the PE multiple, price is the price for the equity, price for the share, E is the earnings per share, so net income per share. If you're looking at something like the enterprise value, then don't standardize it using an equity variable, but standardize using a variable that concerns the entire firm, like EBITDA, like NOPAT, something like that. And then secondly, make sure that the multiple is uniformly estimated. So if you're looking at firms in multiple countries, in principle, this doesn't have to be a problem because you're standardizing all these variables. But for instance, if there's accounting differences between those firms, then the PE ratio that you're estimating for one firm may not be the same as the PE ratio you're estimating for another firm, because for instance, net income is slightly differently defined. So make sure that it's consistent. Then secondly, look at the multiple. So describe a little bit, what does the multiple look like? So you want to know what is the average, what is the standard deviation, simply because, you want to get a little bit of sense of how well does this multiple actually describe the value of any asset, right? So if you have a multiple that has a very big standard deviation relative to its average, then the average value simply doesn't tell you as much because the spread is so big. Or maybe it does tell you still something, but you do need to take into account that the spread is very big. You want to know a little bit about the distribution. So is normally distributed, log normally, uniformly? What does the distribution look like? Are there any outliers that drive the multiple? If so, what do you want to do with those outliers? Maybe you want to throw them out, maybe you want to cap them, so winterize them, or maybe you want to leave them in because outliers still represent real data. So there's still something that you want, there's information inherent with them that you do not want to throw away. And maybe there are cases where you cannot estimate a certain multiple. For instance, if a multiple becomes negative, then it becomes very hard to compare. And maybe the multiple changes over time in that, multiples, the multiple simply looks way different now than it did 5 years ago. So any rules that you had in the back of your head 5 years ago, maybe they don't apply anymore. So to just get you thinking a little bit, let's start by thinking about the PE ratio. So price earnings ratio. If you start estimating that for all companies and graph out the frequency distribution, what will this distribution look like approximately? And think about it. And there, that's going to be a log normal distribution. So why is that? So for instance, here I took some data for the frequency of PE ratios, so the PE as an industry average. So what I did here was look at industry average PEs and then take for each of these PEs the number of firms in that industry. And then make a histogram out of that. And what you see here is this is pretty much like a log normal type of distribution, right? So this means that your average will be somewhere around here, while your median will be somewhere around here. So here, this is immediately a way to kind of get you triggered in terms of thinking about, hey, what is relevant value here for comparing in this industry? Maybe the average is not as informative as the median PE. Also note that, also why is the PE ratio here the way it is? Well, first of all, you won't see that many negative values, because negative values right here that go over here tend to be when the price earnings ratio is smaller than 0. Well, that is the case if net income is smaller than 0. And in that case, yeah, it's highly likely that this company is going out of business sometime soon. Of course, it can still be a growth company, but yeah, in principle, if net income is negative, that's not a good sign. Also, if your net income is negative, then it means that it becomes very hard to use this PE ratio to compare across firms. So suppose you find a comparable firm and that comparable firm has price, let's say it has stock price of 60 and earnings per share of, I don't know, minus 40 or so, then this price earnings ratio is now minus 1.5. So if you then find you have an even worse performance of, let's say, minus 100 earnings per share, so then does that mean that your price is likely to be 150? Well, that seems like a bit of a stretch. So this is just to say that, hey, even if you find a certain multiple, make sure that you analyze what the multiple actually looks like, because you are interested in what the distribution is, and then the distribution can tell you a lot about, hey, how to apply this multiple and how this multiple can be abused, so that you can keep an eye out for that. Then analyze the multiple. So what are the fundamentals that derive and drive these multiples? I'm going to talk about what the fundamentals that drive multiples in parts 2 and 3 of this lecture, because in principle those multiples have embedded values that drive their value. So stuff like growth, like risk, like cash flow patterns, and those will all affect your multiple under the surface, even though you don't really see that in the multiple value itself. And then finally apply the multiple. Yes? And there, again, you have to be careful how to apply the multiple. So for instance, think about what is a comparable firm. So in principle, most of the time you can look at firms in a similar sector and say, hey, firms in this sector are exactly the same. But if those firms differ very greatly in terms of risk, in terms of growth, in terms of leverage, then it becomes maybe a lot harder to apply that multiple. And in principle, you could also take firms from completely different industries that are perfectly comparable because they share similar risk as your company. So be careful in terms of which companies to choose when analyzing your multiples. And then maybe you will also want to make some adjustments given that these firms are slightly different. All right, next part, I'm going to talk about one heavily used multiple and talk a little bit about the fundamentals that drive that multiple, namely the PE ratio. See you there.